What's the one thing better than a Commodore 64 emulator? How's about a Commodore 64 emulator made from a real Commodore 64? Hi and welcome to Bytes and Bits. In a previous video we used BMC64, a Commodore 64 emulator, to turn a Raspberry Pi into in effect a replica Commodore 64, and I used sort of modern keyboards and so on to do that. But at the time I did mention that one of the great uses of that emulator is to actually build a replica Commodore 64. So in this tutorial, that's exactly what we're going to do. So I have a Commodore 64C here. So this is an original case and original keyboard, but there's no actual Commodore 64 motherboard inside of this. If I show that round to you there, so inside the expansion port, you can see that we have a Raspberry Pi Zero 2W in there. And of course that is running our BMC64 emulator and turning this original hardware into, in effect, a replica Commodore 64. So we do have the advantage then of having all of the original hardware, so we get the true feel and an experience of using a Commodore 64, but we then have the advantage of having modern electronics inside it, where we have HDMI output for both video and sound, USB for our gamepads, and so on. So this gives you, I say, in effect the best of both worlds with the true hardware but modern electronics. So let's have a look at what you need to buy and where you can get hold of these bits nice and easily. How we can then put together our circuit board. So we're going to look at a nice, quick, easy and cheap way of building up this circuit board so you can get running up as fast as possible. And then we'll show you how to put it all together and get yourself a really neat retro gaming system with original hardware. So let's have a look at what's needed for that. Now, before we start on the replica hardware, we do need to get a Raspberry Pi set up with the BMC64 emulator installed. Now, I did make a video on this a few weeks ago, so do please check that out, and I'll put a link to that in the description. In this project, I'm going to be using a Pi Zero 2W as the main processor. Now, that isn't actually listed as one of the supported devices in BMC64, but it is based on pretty much the same hardware as a Raspberry Pi 3, and it is actually compatible with that. So if you're going to follow me through with this particular model, then do use the Raspberry Pi 3 image to flash your SD card, and that should then work fine. So to get this project up and running, you're going to need to get hold of an actual Commodore 64, or at least a Commodore 64 case, and most importantly, a working keyboard. Now, your best bet is probably to go on eBay and have a look through there. So there are always a number of these up for sale. So in the UK, as you can see here, for a parts-only one, because again, we don't actually need a working motherboard, and we don't need any of the bits and pieces that go with these, like data sets and game cassettes and so on. So we really just need to get hold of the basic case and keyboard, and generally these will pop up on eBay for around about the £50 to £60 mark. You can sometimes get them a little bit cheaper, but that is generally the investment you're going to be making. And again, that's for a parts-only one. Buying a fully working one, I don't know how you feel about it, but for me, I would feel a bit bad sort of throwing away a working motherboard. Now, the other option, of course, as opposed to buying one of these parts-only sales here, because you are taking a little bit of a chance as to whether you're going to get a good case, whether it's going to be cracked or not, or whether the keyboard actually has been tested and is working. I actually found on the UK eBay there is a really good seller, and this is where I actually bought my pieces from. So I'm sure there are other sellers similar to this. So this fella, Phil6581, he actually takes old computers and sort of strips them out and then salvages the spares from them. And that way you can actually get a very good price on both a Commodore case, so he generally sells them for about £15, and a keyboard then for about sort of £23. So for under £40 you're getting a good quality case and a fully tested working keyboard. So that's what the way I decided to go. And again, you don't then have to worry about spending sort of money on all the other ancillary bits, which we're not actually going to use for this. Now, if you do go down the route of buying a second-hand machine and you find that some of the bits aren't working, well, actually, this fella here who did point me across to his spares website. You will find that there are some people like Phil here who do strip down these computers and then sell off the parts. So if you find that you buy a keyboard and perhaps that isn't working quite the way it should do, you can then start to replace individual keys or key caps or various cables or even down to the springs and so on. So if you do get one that needs a bit of attention, then obviously there are people like Phil here who will supply the parts to fix that and get it back into full working order. But at the end of the day, once you've got hold of your case and your working keyboard, we are ready to go. So the other major component for this project is of course a Raspberry Pi. And BMC64 will basically work on anything up to and including the Raspberry Pi version 3. They haven't yet released a version for the Pi 4 or the Pi 5. So I'm going to be using a Raspberry Pi Zero 2W. Basically that will give me the same power as a Raspberry Pi 3 in a much cheaper package, but more importantly it actually has all of the both power, USB and HDMI connections all down the same edge of the board. So that gives me the advantage then of being able to use one of the cutouts on the back of my Commodore 64 case, and I can simply then just mount my Raspberry Pi in one of those cutouts, and I will then have instant access to all of the ports for the Raspberry Pi. If I use something like a Raspberry Pi 3, the HDMI outputs are down one edge and the USB outputs down the other edge, so I can't actually place that so I have access to everything very easily. So looking at the actual parts then, we have a case and a keyboard. So the keyboard itself is a nice self-contained unit with a really good mechanical keyboard on there. On the back then you'll find a single bundle of cables coming out to a 20-pin female pin header, and that's where we're going to connect then up to the Raspberry Pi to allow it to talk to this keyboard. The case itself then, I've got a Commodore 64C case, which is a two-part case. The keyboard of course fits into the top half of that, and it does, as you can see, a dangling down there is an LED. But the actual bottom of the case is where we're going to fit our Raspberry Pi, and around the back you can see there are a wide range of ports, but we're going to fit our Raspberry Pi so that it fits and we can actually get access to it then. So our Raspberry Pi Zero, if we place it somewhere in this top left corner, or top right corner of our case, we can use the expansion port and we can mount the Raspberry Pi so that we have access then to all of the ports we need to connect up to power and screen and so on. So that's really how we're going to put this all together. So let's have a look and see what we need to do to actually build this up then. So to begin with, let's have a look at the actual Commodore 64 circuit board. So if I zoom in on this particular area here, you'll see that we have some three connectors. So CN1 is our 20-pin keyboard connector. We also then do have two 9-pin joystick ports, the CN8 and CN9. Now, this particular version of the project, I'm going to just simply get us up and running in a nice, simple and easy way. So I'm going to focus in just on the keyboard connector itself and connecting that to our Raspberry Pi. Pi. I don't actually have a 9-pin joystick, so we're going to rely on the USB port on our Raspberry Pi for connecting up any sort of game pads and so on. I will, in some future updates of this project, be going to a full custom PCB where we will start to do a bit more complex stuff and actually map in our joystick connector. So if you do want to use those, we will be able to. But again, I'm going to reserve that for a separate project. This one here is just really using parts that you can get hold of really easily. We're not going to go as far as a circuit board. We're just going to build this up on some prototyping board. But I want to show you how we can actually get a Replica C64 up just quickly, easily and cheaply. But if we have a look at this circuit then, you'll see that the keyboard itself, we have various columns and rows. So keyboards are basically a matrix of switches, and the this 6526 CIA, this complex interface adapter, it really just cycles through various columns, looking at which rows have been clicked, and that will then come into our main CPU, and we'll be able to decode those as actual key presses on our keyboard. So of course, BCM64, BMC64, it is going to mimic these. So we are going to connect these columns and rows up to I/O pins on our Raspberry Pi, and then the software itself will then be, in effect, scanning those to check for our key presses. So if we have a look at the actual circuit we're going to have to build, and I've built it up here in a package called EasyEDA, and again, all of these circuit diagrams and details, I will publish those out, so do please have a look both in the description down below, and also check out the project page on my main bytesandbits.co.uk website, and again, there'll be links for that in the description as well, and you'll get a hold of all this documentation. But if I zoom in on this particular circuit then, you can see we have our Commodore 64 keyboard connector here. So we're going to use a 20-pin header on our circuit board, which will allow our Commodore 64 socket to plug into that. So on the actual keyboard connector itself, you will find it's a 20-pin header, but pin 2 is blanked out, and that then is the key for this. So on our pin header, we will need to cut out the pin for pin 2, so that our keyboard connector can actually fit on. And again, that makes sure that we always get our Commodore 64 keyboard connector the right way round. You can see then that the various pins on that header are really just routed across directly out to pins on our Raspberry Pi. There is no any of the sort of external circuitry that was on the Commodore 64 circuit board for various filtering and so on. But we don't need any of that here. We're just simply going to be using our column pins to drive signals out onto the keyboard, and we'll then get returns from the actual key presses through on our row pins, and they'll be fed straight back into other GPIO pins. So the actual circuit itself is just simply a series of wires between our Raspberry Pi header and the keyboard header. The only extra thing that I'm going to build onto this is the little circuit for the LED on the case. So that just gives our little power LED. So if we have a look actually on the real Commodore 64 circuit, you'll see that detailed here. So we have a little 3-pin header, and that really is just using a little current limiting resistor. So the real circuit uses a 390 ohm resistor, which we will just replicate that, or something very close to that, sort of 330, 390, or something close to that, whatever you have easy to hand. And that just simply connects between the 5 volts on our Raspberry Pi. So again, we're going to be powering our Raspberry Pi through USB. So pin number 2 on our header will actually have the 5 volts from our USB pass straight through to that. And we'll just connect that up then to a little header on our circuit board, and we'll be able to then plug our cable from our LED actually attached to our case into that, and we should then get our little LED coming on when we power up our Raspberry Pi. So that's pretty much the circuit that we need to build. I'm going to do it on some prototyping board, some matrix board, and I'm going to take you through that. If you do want to put that onto an actual PCB, everything here we can do using through hole. So if I just flip across to a little PCB layout here, We can do it all using through-hole stuff, which makes it very easy for us to make a little circuit board at home. And again, I'll be covering that in a next tutorial. I do want to go through an actual tutorial on making our own PCBs at home, both through-hole ones like this, and then just slightly more complicated surface mount ones. We can actually do that all by ourselves. But I'm going to leave that for a separate video. But I say, if you do want to go and make one, I will put this little layout online as well. As you can see, it's very simple. It just runs a number of wires between the two headers. So let's start to build this up then. So before we actually connect up our circuit, we do need to change some settings in the BMC64 installation. So use the F12 key to get into settings, go to GPIO, and then in the config we need to change that to option 2. So this tells BMC64 that we have connected a keyboard and potentially some joysticks. So it will then start to run those scan lines on the matrix to read in the actual key presses. So next we need to go to keyboard, and we need to change our mapping, which will probably be in symbolic when you first come in, but we need to change that to positional. So that will now map our real Commodore 64 keys to the actual key functions. So once we've done that, head down to the Save Settings and select that. That will then save everything onto the actual hard drive, so that when we reboot, we will boot up and we will have then support for our real Commodore 64 hardware. So with this sort of project, I would always advise you build it up on some sort of breadboard to begin with. And really this is going to let us test out all the individual parts, just to make sure that we've got everything actually in working condition and that our circuit is actually correct. So here you can see that I've used some breadboard. I've got an extension cable for my Raspberry Pi GPIO header, and really just building it all up, connecting up my keyboard, and this will then let me test it out to make sure that both my keyboard is working, my circuit is correct, my Raspberry Pi is all set up correct, and that I can actually get a working Commodore 64 just sitting here on my desktop. Now obviously this then makes it a lot easier, because if I can test it here and I've got everything working, then I know that if I do put my circuit together that I've wired up by hand, then if it doesn't work, it's something is wrong with my circuit, rather than trying to work out whether it's actually something wrong with my keyboard or my software or whatever. So it just means make sure that you actually have a baseline where you know that all your individual parts are working. So the circuit board I'm going to build is basically, as you can see on screen here, it's 3 headers soldered onto this bit of matrix board. So we have our 20-pin header for our keyboard. We then have a 40-pin GPIO header, and then a separate 3-pin header for our LED. Now I'm using a male pin header for the GPIO, and really what that lets me do is I can either use a ribbon cable to connect off to something like a Raspberry Pi 3, which I would mount somewhere else in the case, or as I'm going to use here, I'm going to use a Pi 0. Now you can either fit your Pi 0 directly onto this header and solder it in place, which will give you a really firm connection, or I'm actually going to use a female header on the bottom of my Raspberry Pi, which I can then just plug onto the top of this, which is a slightly wobbly connection, but it does work, and it does mean that I then can take my Raspberry Pi back off again if I need it. So how you actually build a circuit board up is really up to yourself, whatever technology you prefer. So I like using this matrix board, and really I like this because I can really place the components anywhere I want. I can get a nice density of components here. I don't have to leave lots and lots of space. And then on the back of that, I really just use some very thin wire to hook up the various connections and just solder those into place. So you can see here the actual wire itself is very, very thin, and I use this and it is insulated, so I do need to strip off the insulation, and then I can just wire from point to point. But it does mean that I can get a very neat circuit, and I can really make it whatever shape or whatever size I want to, and it is quite quick and quite easy to put together. Now, one thing that's very important to get correct here is the orientation of your GPIO header. As you can see from the photograph, it's designed so that the Raspberry Pi will fit on there with its connectors then pointing out through one of the cutouts in the case. So make sure you wire it up in this orientation. So once you've got everything built, do make sure you go through and check your point-to-point connections just to make sure you haven't made any mistakes. And then it's time to put everything together. So first off, I fitted my keyboard to my case. So that really just slots into the keyboard. Make sure you get it underneath the tabs at the back. Put it into place, and then it should clip into place with the tab at the front. And that just simply holds the keyboard then in place actually on the lid of the case. We then need to extend the wires for the LED. So I'm putting my Raspberry Pi over at the expansion port, which is on the far right hand side. So I just need a little bit of 3 wires just to extend my LED connector, and that's the top of the case ready to go. In the base of the case then, this is where we're actually going to install the circuit board itself. So I'm using these little stick, these sort of glue pad standoffs. So that will just let me just put some on each corner of my circuit board. So I've drilled those holes out a wee bit just to make space for these connectors. So they just simply push into place, like as you can see in the video at the moment. So all 4 of those. Once those are in place, it's time to put the Raspberry Pi onto its header. And you can see I've used an actual stacking header on my Raspberry Pi, so I still have access to the pins above the Raspberry Pi. Then comes the most difficult part of the build, which is getting the bloody backing off these little sticky pads. So work your way through that. And here, perseverance and long nails are the key. But then eventually you should be able to place and stick your Raspberry Pi into the expansion port. And I'm lining mine up so that the actual connectors are fairly flush with the back of the case there. Then just press it down into place, and that should be your Raspberry Pi installed. And you can see there that we now have access to our USB, power and HDMI connections. So after that, we need now to bring in the top of our case back in again. So we have our connectors then for our LED. The 3 connectors, the center one of course is the 0 volts connection, and then either side should then go off to the LED. Of course only one of them is actually the wire going off to the LED. So if it doesn't come on and you haven't wired up all 3 pins, do make sure that you just change it around a bit, and that LED should then come on as you power on your Raspberry Pi. And with that then put in place, our keyboard connector goes into place. And again, make sure you line up that pin to key so that it fits into the connector. And then it's just simply a matter of closing up our case. So my C64C case, we have some pins at the back of it. So we have to get those into place, which I did find a little bit tricky here. And then it then has a number of those clips at the front, so we just need to push those into place. And we should now have a fully complete Commodore 64 replica. So everything is all closed up. And if we have a look at the back of the machine, we should be able to see that our Raspberry Pi is sitting in there, and we're all ready to plug it in and give it a go. So if we hook up our HDMI, our gamepad and our power, we should have a working replica Commodore 64. And if we then just have a go with the keyboard, so you should be able to sort of find out there, just check all the keys are actually working, and that should be you up and running. Now, when I first did this, I actually thought that everything had gone wrong. And if you look on the screen there, you'll see that the actual key presses are coming up all funny. What it's actually doing is, as I was fitting my keyboard, I actually hit the shift lock, which is actually a latching key. So as you press it down, it locks in place. So if you do get something funny coming up, do check that. It took me a few minutes to work out what was actually going on here. So that's our replica Commodore 64 all up and running. So we now have the full experience of using a real Commodore 64, because those are real parts, but with the added advantage of having modern HDMI output for video and sound. We have a USB port for plugging in our gamepads, and of course, once we load up all of our software, we actually have the entire Commodore 64 software catalog all built into this one nice unit. With using BMC64, we also of course have access then to a VIC-20, so we can turn this into a VIC-20 at the click of a button, or a Commodore PET, or any of the other Commodore 64 variations. So from my point of view, this gives us a fantastic retro gaming experience. So in this video, I've concentrated on the sort of fast, cheap and easy way of making up the circuit board. And you can see here, the total cost for me was just under £70, and you'd be hard pressed to buy a real working Commodore 64 for that price. Now obviously in the future, we're going to go to full custom PCBs and bring in joystick support and so on, but we'll leave that for another day. So I hope you've enjoyed this. Please do like and subscribe to the channel and keep an eye out for those next videos. I look forward to seeing you again very soon, and bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.